Hello, students. So this lecture is about the physiology and homeostasis. So this is our first lecture, and so basically it's an introduction of the physiology. So let's look at what are the basic about the physiology. And so this physiology basically is the function of human body. And you may have learned, I think it's required to already learn about the anatomy. So you learn the structure. And with this one, you will learn about the function. So that is the basic idea about the physiology. When you talk about the function, you can have these function in different level. You can function in the cellular level, and then cell combine together to form an organ. Uh, for example, every organ is constructed by different cells, and this organ will perform its function. So you have a heart as an organ, perform its function, brain as an organ to perform its function, and all this organ has a is a combination of many cells. So you have those. So we will talk about those. Um, And so that's that. We was this is just the introduction, an overview, and then we will later lecture. We will learn about nerve cells, muscles, organ, brain organ, nervous system, heart as an organ, the renal system, the lung, etc. So basically, that's what we are going to learn. And of course, when we mention about these organs, we will also talk about their structure, talk about their anatomy. And so have a good understanding of their anatomical structure will help. So in addition to the physiology, one thing also very important is to know that our body as a whole, the whole body combine together, integrate together to perform important function in order to maintain a stable internal environment. And so we call this a homeostasis, that internal body is stable. Um, we try to maintain stable environment uh, in in different area. For example, your body temperature is stable. And so no matter how you do, no matter what you do, no matter you are in the winter time, you are in the summertime, your body temperature will be stable. So that is the homeostasis. Your blood pH level will also be stable. And so no matter you drink uh, soda that is more or less acidic, or you drink water which is pH neutral, or you drink something that is more alcoholic, more basis. No matter what you drink, or no matter what you intact into your body will try to uh, make correction, so your blood pH will be stable. And so our body try to maintain several things that is stable because we need to have the environment for our chemical to function. So all these chemical in our body, they have this chemical process. They need to have the stable pH, a stable temperature, so they can perform well. So that's the homeostasis. Our body, the system to maintain this homeostasis is called homeostatic feedback loop. It's right here, if you can see my mouse right here. Homeostatic feedback loop. This loop will describe how our body use different components to stabilize a parameter, whether that is a temperature, whether that is a pH, whether that is your blood pressure, whether that is your uh, uh, energy level, so everything. So our body will try to use a homeostatic loop. For each one, we will have a homeostatic loop. For temperature, we have a temperature homeostatic loop. For pH, we have a pH homeostatic loop. And in each loop, this loop will have a couple components in this loop. The components include a sensor to detect it. So you want to maintain your room temperature. You got to have a sensor to detect your room temperature first, right? So with that reading, you can maintain. You want to measure your patient's body temperature. You got to insert a thermometer to your patient's body, right? So you can measure the body temperature. When your body try to maintain your own body temperature, you got to have a sensor to monitor it. So you have a sensor for all those parameters that you try to maintain homeostasis. You try to maintain stable. When sensor pick up any variables different from the stable level we call it a set point. Then it will send signal into the integrator. Then integrator will send signal into the effector. And then effector will send signal called a response. And then response will reach out the result. The result usually is to correct that variation. Yeah, so it may sound pretty vague. Let's use some example. For example, yeah, so you will need to, after learning this homeostatic loop, you will need to be able to understand what are the variables for example, stimulus. It's either hot or cold. What is the sensor? What is the integrator? What is the effector? What is the response? What is the result? So you will need to know that. Let's use some example. For example, oh, just before I jump into the example, something that we need to know, the terminology. So first one is a set point. You need to know that um, our body, we don't try to maintain everything. You cannot maintain everything. You cannot maintain your body weight, right? Your body you will get gain weight. You may lose weight. Your body has a certain level, but you don't set point. You don't set a normal, like stable number on it. If you eat more, your body will try to accumulate. So that's the thing that you don't set. You don't try to stable. You don't try to maintain stable. But there are several other things, as I mentioned earlier. Our body will try to maintain stable, such as temperature. So we have a set point. We have a set point for your body temperature. For example, pH. You have the set point for your blood pH. So it has to be around that range. If it's too high, it will trigger a homeostatic loop. If it's too low, you will trigger a homeostatic loop. Our body also try to maintain a blood pressure. If it's too high, it will trigger it. If it's too low, it will trigger it, trying to maintain it. So we have the set point. So that's the thing, that your body is like a standard number, more or less. We are the same, but there are individual difference. Yeah, so we have the set point. So that's the set point, the ideal normal value for a variable, such as temperature, body temperature, such as body pH. Now, if that number is different from the set point, we call it an error. For example, if your body temperature is supposed to be 99.8 Fahrenheit, and then you get to 101, for example. So that difference, let me see, 101 and 90. pencil. So for example, if you measure body temperature, say 100, right? 100, but your body's set point supposed to be 99. How about that? 99. Then what is the error? The error will be 100 minus 99 equal 1 degree. So you have a positive 1 degree of your body temperature, and then it will trigger this homeostatic loop. Stimulus, that is the error. Sensor, your body thermal receptor to detect that error. Send to your brain, tell you that you are so hot, you are getting hot. The effector is you will start swelling, reduce to bring the temperature to the body surface, evaporate it, and then you cool down, and your body temperature will return to the normal level. So that is the error. There are situations that you cannot correct it. The error is either too large or your body lose that normal physiological function. So this feedback loop is a result of normal physiological function of your body. If your body lose that physiological function, we basically call that you are sick, right? You need help. You need to take Tylenol. You need to take a pill. Yourself, just depending on your body's organ system, you cannot correct that error. When that situation happens, we call it a disturbance. That you cannot get back to the original set point by using your homeostatic loop. Yeah. So that's the terminology. All right, we want to see some example. For example, just this basically is the thing that I talk about. So stimulus is the environmental signal, like in the body, still environment, right? Your cells will sense it, or your body's body temperature, pH, etc. So that's stimulus. The error of that value different from the value that's different from the set point. So that's stimulus. Sensor is a body part to detect that difference, to detect that stimulus. So stimulus is very much like an error in a way that it's fixable. So if that error is fixable, if that stimulus is fixable, that is an error. If that stimulus is too big or your body lose the physiological function, it becomes a disturbance. So you have that variable, that difference of that measurement detected by your sensor. Your sensor is a body part. So when I ask that, what is a sensor for your body temperature? You need to know what is a body part. We have the sensory cell in your skin that can detect your body temperature. You have the sensory cell to in your blood vessel to detect the pH level. So those are the sensor. Sensor is a nervous system. Usually it's a nervous system. We have the sensory neuron. If you have learned about the anatomy, you probably learned about that. We have a different kind of sensor, chemoreceptor, right? So it's a receptor right here. It's a receptor right here. So it's a receptor. We can have chemoreceptor. We have a thermal receptor. So those serve as a sensor. Then the signal was sent into the integrator because you have multiple thermal receptor on your skin. Part of it will pick up some heat, part of it will not. So you need to integrate all this information into a central area. And then central area will send out a signal. So this one sensor will send in a signal. We call it an afferent signal. The integrator will send out a signal. We call it efferent signal. This efferent signal will then trigger the effector. This effector will do the work. it will have the function, it will have the activity trying to fix that error. So the response is the action provided by the effector. So effector is again, so sensor is a body part, integrator is a body part, effector is another body part. This one will perform the function, the action to correct that variables. And then the response to it is the effector is the one to provide the action, and the action is called the response, and then the result would be correct to correct the error caused by the stimulus. So let's look at one example. We have two examples in this lecture. The first example is the body temperature. So basically, you want to maintain your body temperature. Your body want to maintain your body temperature. Then how does your body do it? It has to have a sensor. So here you go. So your sensor, your body sensor, thermal receptor is in your skin. You can feel hot, you can feel cold. It's because of your skin. Now, when you feel hot, when your sensor feel hot, right here, if your body temperature is high, then this thermal receptor, the nerve, will send signal into an integrator. Here is the integrator, which is in the hypothalamus. So this region is called hypothalamus right here. Where is it? It's in the very lower portion. So this is your brain. This is very lower portion of your brain. This triangular area right here. This region. This is brainstem. So this is lower but not too low. So this brainstem, pontine, medulla, and underneath this one is spinal cord. And so in this area, in this triangular area, this is called hypothalamus. So your hypothalamus is the integrator. It will gather the information from all these input signal, all these afferent signal. And then you will decide that, okay, somebody told me that it's hot, right? Is it true? And if you collect the information, really, if this temperature is above the set point, then it calculates it, it gets error, the error is positive because the temperature is high, and then it will send out an different signal to different effector. We have the blood vessel effector, we have a swelling effector, we also have a thyroid. We don't really talk too much about the thyroid, but it's another effector that will respond to the high body temperature. So for example, and then these are the effectors, and then they will have its action. For the circulation, you will bring more of your blood into your skin so you can evaporate this temperature into the environment. You will go to the cold room, right? Turn on your fans or your air conditioner, make the room cold, and your blood will go to the surface, evaporate it. So that will cool you down. You will also start to sweating glands also in the skin. So this is effector, and the response to that signal is to start to sweat. You have the effector always. It just doesn't sweat, right? It doesn't sweat if it's not hot. Now, if it's hot, these hypothalamus will send out signal, the efferent signal, to act on it, to cause it sweat. When you sweat, you reduce the body temperature, and so in the end, you can correct it. The result is to reduce your body temperature. So just one example. Another example will be here. If the body temperature is low, if you are in the winter and you didn't wear a lot of clothes, then your body temperature is low. Thermal receptor pick up the signal, tell the hypothalamus, hypothalamus send out efferent signal to blood vessel. Now, because you are cold, you cannot circulate in your blood into the skin, the surface of the skin. So they will bring the blood only to the lower level of the skin. So you can preserve your body temperature. It will also act on your skeletal muscle to cause you shivering. You will start to shiver. When your muscle shivering, it also generates heat. Like your exercise, you generate heat. So that will bring up, or altogether, they will bring up your body temperature. And so that can correct it. So this is example that when your body temperature change, you have the sensor to detect it. Send to the integrator, hypothalamus. Send to the effector, the skin, blood circulation, muscle, or sweating gland, and then they will have the response. Then the result is to correct your body temperature, to bring it back to the normal level. So knowing all these, we can fill in the question I provided to you earlier, like this one here. What is the stimulus? What is the sensor? Is this body part? What is the integrator? This is another body part. What is the effector? That's another body part. Response is its action. Result is the result is to correct your body temperature. So we can fill in, we can start to fill in this homeostatic loop. And we can convert this picture into that homeostatic loop right here. For example, if the body temperature is high, stimulus is the temperature. So this is a variable. You got to have something to pick this variable to detect it. That is a sensor. Thermoreceptor, this is part of the sensory neuron, sensory nervous system. It detects this temperature change, sends signal into the integrator. For the body temperature homeostatic loop, the integrator is hypothalamus. Then this is sends out an efferent signal to skin, blood vessels, and the sweat glands. So the effector is skin, skin's blood vessels, and the sweat glands. They will have action. The action is a response. A blood vessel will dilate in the skin. So you have more blood going to your skin to increase, release heat from your body surface. You also sweat, so you can guide this body temperature, body heat into your surface, body skin surface, and then you can reduce your body temperature. And the result is to decrease your body temperature back to the normal, back to the set point. Another example is glucose. Our body will also try to maintain the blood glucose level. You don't want it to be too high or too low. It can be, even if you eat, your glucose level increase, you want to bring it down to a normal level. If you are hungry, you have not eaten anything for a whole day, you will also bring it up. So your body, your cells, your brain has glucose to use. So it also has a homeostatic loop. So here is the set point. The set point is around this number, 70 milligram per deciliter to 130. So this is your blood glucose level. You don't need to remember the number, but you just need to know that there is a set point of those measurements that your body really care about. And so here is that if your blood glucose level increase, what happens when your blood glucose level increase? When you eat food, right? You digest, right? And then it will stimulate. These will be detected by something. What is a sensor then? What's a sensor to detect your glucose level high? The sensor to detect your high blood glucose level is beta cell in the pancreas. So this is pancreas. So the sensor is a beta cell. When beta cell detect it, beta cell will by itself integrate the signal and perform the function. So beta cell will integrate this information, and start to release the insulin. So that is its action to release the insulin. Insulin will act on the effector. We have three major types of effector, but in this picture, it only show you two, but that's okay. Basically, it will act on the effector of the body cells. Basically, you have muscle cells, you have the lipid cells. Insulin will act on them to cause them to uptake, to absorb this high blood glucose into those cells. So they will take in the glucose. And so you can reduce your blood glucose because all this glucose from the blood shattered, travel into these cells. So they get stored in the cells. It also gets stored in the liver. So you can, when your blood glucose level is high, the sensor is the beta cells in the pancreas. It will do something. It will release insulin to act on the effector. These cells will then collect the glucose in the blood and store them in the lipid, in the muscle, and in the liver. And so they all collected. You don't have too much remain in the blood, so you can bring back your blood glucose level to a normal range. In the opposite direction will also work. If your blood glucose level is low, for example, you have not eaten sugar, you have not eaten carbohydrates for many days, then your blood glucose level will drop. But your blood glucose level cannot be too low. Otherwise, your brain don't have the glucose to do the work. Your body cells need glucose to produce ATP to produce the energy. So you need glucose. And in order to prepare your body for that glucose level, something need to detect it, the sensor. The sensor to detect the low glucose level in the blood is alpha cells in the pancreas. So the alpha cell sense it. Alpha cell by itself will integrate this information, and then it will cause it to release glucagon. Then glucagon will act on the liver, and also some other organ. Basically, lipid glucagon will cause these organs to release. Remember, they store right here. They store this glucose. They store the glucose as a glycogen in the liver, as a glycogen in the muscle, and as the fat in your fat cells. Glucagon then will come to them, ask them to come on. We don't have enough glucose in the blood. Please release some. Then these organs will start to release the glucose into the blood, and then you can bring back your blood glucose level. So you can maintain your blood glucose level through a homeostatic loop. And again, we can fit this into the diagram, this homeostatic loop diagram to show what is the components in your body to maintain blood glucose level. So let's do it here. Here, that's the last slide. So that's here. So stimulus is either increase or decrease in the blood glucose level. We have the set point. If it's high, then the arrow is a positive number. If it's low, the arrow is a negative number. And then the signal, if the stimulus is high blood glucose level, then which sensors detect it? The sensor will be the beta cells in the pancreas. Beta cell sense it, beta cell integrate the information, beta cell integrate the information, beta cell will also respond to it, will also do something, the efferent signal will be the releasing the insulin. Then insulin will act on the effector. The major effector respond to insulins are muscle cells, fat cells, liver cells. Then these cells will start to store this blood glucose. You have a lot of glucose in the blood, insulin will tell them, and these cells will start to collect the glucose in the cells. And so you can response is to uptake the glucose, store as glycogen in the muscle and liver cells, store as a triglyceride, that's a fat in fat cells. So you collect them from the blood, and so blood glucose level can return back to normal. So that's an example of another example of the homeostatic loop to maintain the several homeostatic status in your body, including temperature, including glucose. Why do you need to learn this? Why do you need to care about the homeostatic loop? The reason is you may not care what components play a role here to maintain your glucose level. Doesn't really matter. They do the job. Why do I care? The reason that we need to know this system is that unfortunately, not everybody and not every day, not like you can maintain it normal forever. We have a disease called diabetes mellitus. And what's that disease? That is a disease that you have high blood glucose level. You cannot fix it. The patient will have hyperglycemia, high blood glucose level. And so in that situation, what caused it? Why can't you correct it? Is a disease. Why? Because you cannot maintain it. You cannot correct any error caused by high glucose or low glucose level. And that become a disturbance. That is a disease. You need treatment. And when we come into the situation that the patient cannot correct it, we will need to find a way to help the patient. You will need to see doctor. Doctor will need to find whether that is a beta cell disease, whether that's insulin disease, whether that is muscle, fat, liver, lack of the sensitivity to insulin. So that is why we need to know this homeostatic loop. The reason is, when we know this, in the future, when we learn about this disease, we have a concept, we have the idea what could be the place, what could be the body parts is injured or is abnormal and to cause that disease. So that ends it. Thank you guys. I will please let me know if you have any questions. Bye-bye.